Hello, up there. Today I'm going to show you on how to solve simultaneous equation by Cramer's rule, which is the easiest method to find the value of a node in any either 2 by 2 matrix, 3 by 3 matrix, or 4 by 4 matrix. So let's dive into the lesson. Example, we're given 2 by 2 matrix and asked to find the value of a node which is x and y. So if you write this equation into matrix form, it will be like this. Therefore, to find the value of x is going to be d1 of d. d1 meaning it will be the determinant of one of the original determinant. So determinant of the first. So for x, we're going to denote the coefficient of x and we put 1 and 7, which will be 1 and 7, and then coefficient of y will remain constant, and the original matrix will find its determinant. This will be 2, 3, negative 3, and 1. From there, it's going to find the determinant is going to be 1 by 1, which is 1, we subtract negative 7, multiplied by negative 3, which is negative 21. So it is going to be, if we open the bracket, it's going to be positive 21 plus 1, which will be 22. And on the denominator side, it will be 2 by 1, which is 2, subtract 3 by negative 3, which is negative 9. So it's going to be 9, 2, minus 9, which will be positive if we open the bracket. So it's going to be 2 plus 9, which is 11. So 24 divided by 11 is going to be 2. Then the value of y is going to be the determinant of 2 over d. So here we're going to, the coefficient of x will remain constant, but the coefficient of y will change by putting 1 and 7. So the coefficient of x will remain 2 and 3, then coefficient of y will change, which will be 1, 7, then the denominator side will be the original determinant, which is 2, 3, negative 3, and 1. So it's going to be y is equal to 2 by 7, which is 14, we subtract 3 by 1, which is 3. So it will be 14 minus 3, which is 11. Because you already find the denominator, its determinant, you're going not to repeat here. So you're going to put 11 on the denominator side. So it's going to be 11 over 11, which is equal to 1. So you already find the value of x, which will be 2, and the value of y, which will be 1. So let's go on how to find the value of x, y, and z on 3 by 3 matrix. So first we'll write the matrix into its form, which will be like this. So from here, to find the value of x, the first step we're going to be d1 over d, meaning the coefficient of y we are going to remove and put 9, negative 2, and 8. So it will be 9, negative 2, and 8. Then coefficient of x will remain, and the coefficient of y will remain. Then we are going to divide with its original matrix, which will be 2, 1, 3, 1, negative 1, 2, negative 3, 2, and 2. Then from there, we are going to find the determinant of the numerator, which will be, because we remember the array of sign is added by positive, negative, and positive. So it's going to be 9 multiplied by positive will be positive 9. Then you are going to multiply by its minor. Minor of 9 are going to denote the row and the column. So it's going to be 2 multiplied by 1 is going to be negative 2. You subtract 2 by 2, which is 4. So it's going to be negative 2 minus negative 4, which will be negative 6. Then 1, if you multiply by this negative, is going to be negative 1. So you also find the minor matrix of 1. So you're going to ignore this row and the column. So we remain with negative 2 by 2, which is negative 4. You subtract negative 4, negative 8 multiplied by 2, which will be negative 16. So negative 4 minus negative 16 will be negative 20. Also here it will be negative 3 multiplied by 2 will be negative 3. And we also find its minor. So minor we're going to ignore the row and the column. So it will be negative 2 multiplied by 2, which will be negative 4. Then you subtract it by 1, which will be negative 8. So negative 4 minus 8, which will be 4. And on the denominator side, it will be the same. 2, it will be 2, negative 1, and negative 3. But we ignore the coefficient, the row and the column, so it's going to be negative 1 multiplied by 2, subtract 2 by 2, which will be negative 6. Also here it will be For 1, it's going to be, ignore the row and the column. So it's going to be 2 by 1, subtract 3 by 2, which will be negative 4. And for negative 3, it's going to ignore row and the column. So it's going to be 2 by 1, subtract 3 by negative 1, which will be 5. So if we solve on the denominator, we're going to get negative 46 over, on the numerator side, we're going to negative 23, and on the numerator side, we're going to be negative 6. So negative 46 over, so it's going to be negative 46 over negative 23, which is equal to 2. Then for y, it's going to be d2 over d, meaning the coefficient of x will remain constant, but the coefficient of y we're going to change by this function. So this coefficient of x, y we're going to ignore and put this function. So it's going to be like this, and the denominator side will remain with the original matrix. So it's going to find only the denominator on the numerator side, which will be positive 2, negative 9, negative 3. So positive 2 will be multiplied by negative 20, where negative 20 it was the minor matrix of 2. By ignoring this row, column and row, and multiplied 2 by negative 4, which is 2 by negative 2, which is negative 4. Then you subtract it by 2, which is 16. So negative 4 minus negative 16 will get negative 20. Also negative 4, it was get by the minor of 9, which we ignore this one and this one. So it will be 2 by 1, we subtract 3 by 2, which will be negative 4. Then minus 3, 14, it will be minor matrix of negative 3. So it's going to ignore the row and the column. So it's going to be 8 by 1, we subtract 3 by negative 2, which will give you 14. And on the denominator, because we already find on the value of x, we already find the denominator matrix, it was negative 23, so it will be negative 23. So if we solve on the numerator side, it will be negative 46 over negative 23, which is equal to 2. For the value of z, it will be d3 over dt, which is equal to, so here we are going to remain with the coefficient of x and coefficient of y, but coefficient of z we are going to change by the value of the function, which was 9, 2, and 8. So it will be like this, and then on the denominator side, it will be the original matrix. So because the original matrix already find its determinant, it was negative 23. So we're going to find the determinant on the numerator. So it's going to be 2, we subtract its minor matrix, which is negative 4. Then 1 multiplied by negative 1, which is negative 1. Then we multiply it again with its minor matrix of 1, which will be 14. Then you add 9, because 9 multiplied by positive, it will be positive 9. Then its minor matrix is going to be 2 by 1. We subtract 3 by negative 1, which will be 5. So if we solve the numerator side, it's going to give you 23, and on the denominator side is negative 23. So it's going to give you negative 1. Thank you for watching my video. Remember to subscribe if you like my video. Bye bye.